Okay, so we have here x is minus pi plus square root of 5 plus pi squared, and we're assuming x is rational, meaning that x equals p over q, where p and q are both integers, q is not 0, and the greatest common divisor between p and q is 1. This is just the definition of what it means to be rational. We'll assume that x is rational, so that means p over q is equal to minus pi plus square root of 5 plus pi squared. So that would mean that p over q plus pi is equal to square root of 5 plus pi squared. Squaring both sides, we get p squared over q squared plus 2p over q pi plus pi squared is equal to 5 plus pi squared. Cancelling the pi squareds out, we can say that 2p over q pi is equal to 5 minus p squared over q squared. That means pi is equal to 5q minus p squared. So let me just be careful here. I'm multiplying by q and dividing by 2p. So that'd be 2p q squared, 5q, and then p squared q. You can cancel the q with this power, the p with that. So you get pi is 5q over 2p minus p over 2q, which is 2pq, 5pq minus pq. So then pi will equal 4pq over 2pq. Interesting. Therefore, pi will equal 2, which is clearly false. Which then implies that our assumption was wrong, that means x is irrational. Wasn't quite expecting it to take that turn. Five PQ. Oh no, didn't quite, I don't know. Yeah, I took a bit of a wrong turn. That would be 5q squared. I'm multiplying above and below by q minus p squared. Okay, that's a bit better. So that would mean that pi would equal a over b, where a is an integer, because a is 5 times an integer squared minus an integer squared, and b is an integer, because b is twice an integer by an integer, and this is also clearly false, which means x is not rational but irrational. Yeah, there we go. I wasn't quite expecting all the p's and q's to cancel out at the end, so this is right now.